Hi, I'm Cassie, and I'm going to walk you through question 33 of the AAMC's official physics question pack. So this is a question related to passage 5, which is all about electrical circuits and specifically capacitors. And let's think about what's going on here. Basically, what they're asking is they're saying, originally we have a circuit that has one capacitor. So here's our battery with our negative end and our positive end. And here's our original capacitor, our two parallel plates next to each other. And I'm just going to put this a negative and a positive so it's easier to tell that this is our V, our battery. What happens if we add another capacitor in series with the original capacitor? What happens to our overall capacitance? Well, to understand this, we need to understand how voltage works in a series circuit. So in a series circuit, there's only one path for current to flow. Current can only flow, it has to go through the circuit on this one path. Therefore, it's going to have to pass through each component of our circuit, one after the other. In other words, let's call this capacitor 1 and this one capacitor 2. Our current is going to have to go through capacitor 1 first before it gets to capacitor 2. Now, each time the current passes through one of our components of our circuit, it's going to experience a voltage drop. When it goes through the first capacitor, we're going to call that voltage drop 1, and when it goes through the second capacitor, we're going to call that voltage drop 2. So if we think about the total voltage of our series circuit, so I'm going to say VT, how are we going to calculate that? Well, it's going to be equal to the sum of the voltage drops across our different components of our circuit. In this case, we only have two components of our circuit, our two capacitors. And this would apply if we kept adding capacitors in series. If we added a third capacitor, we'd have plus V3, the voltage drop across that capacitor. If we added a fourth capacitor, we just add that on to get our total voltage here. So what does that mean about how the total capacitance of our circuit changes as we add that second capacitor in series? In other words, how does having this second voltage drop affect the capacitance of our series? Well, we know that capacitance, we said our general equation for capacitance is just charge, Q, stored at a certain voltage. So you can think of it like with those voltage drops caused by adding the extra capacitors, you're essentially decreasing your voltage here. And since voltage is in the denominator of our equation, it has an inverse relationship with total capacitance. So our total capacitance is going to decrease too. So that's why we can use this equation. We're going to use the inverse. So the inverse of our capacitance is equal to 1 over the capacitance of capacitor 1 plus 1 over the capacitance of capacitor 2. So that's going to be our equation for understanding how our capacitance changes when we add capacitors. Since we have inverses here, the more of these capacitors we add, the lower our total capacitance is going to get. So if we go ahead and look at our answer choices, we're looking for an answer choice that says when we add that second capacitor, it's going to decrease our total capacitance. Now, the only answer choice that matches that for me is answer choice A, which says our total capacitance is going to be half as great. Now, let's check that out with numbers just to make sure you understand why it's exactly half as great. So let's say that first capacitor in our circuit, it had a capacitance of 1 farad. So what is our original total capacitance? Well, it's just 1 farad, right? But then we add in that second capacitor, and let's say that second capacitor also has a total capacitance of 1 farad. Now, what's going to be our new total capacitance of our circuit? Well, let's use our equation here. So we're going to have 1 over the total capacitance of our circuit is going to equal 1 over 1, right? Our first capacitor, 1 farad, plus 1 over 1 farad again. So what do we get? We get 1 over CT equals 2, and then we have to take the inverse of that, right? So we get our total capacitance is now a half a farad, when originally our total capacitance was 1 farad. So that's just showing you again how this works with numbers. Now, I do want to take the time for you to review quickly how this would be different if we were adding a capacitor in a parallel circuit instead. So here on the right, I went ahead and drew a parallel circuit that has two capacitors in it. Remember, parallel circuits are different than series circuits because there are different paths that the current can take. So unlike in our series circuit where we said our current has to just go sequentially around the circuit, in our parallel circuit, our current has options. Our current could take this path and go around this way, or it could also take this path and go around this way. So how does that affect the voltage drop across different components of our circuit? It means each component of our circuit, in this case, each capacitor, is going to get the full voltage from our battery. So if the voltage of our battery we're going to call V here, then this capacitor 1 is going to get the full voltage V. That's why that current can just go around this path only. So then there's no other voltage drops that it comes across. So it gets the full voltage from the battery. And our second capacitor here in the other branch of our circuit, it's also going to get the full voltage from the battery, our full V. Because again, that current can just go straight to it and go all the way around the circuit. It doesn't have to encounter any other components on the way. So for parallel circuits, instead of adding up the total voltage of each of our circuit elements, we're just going to say that all the voltage of our circuit elements is equal. So we're going to say our voltage total is equal to, we'll call this again, V1 of our capacitor is equal to V2 of our second capacitor. all of these things are exactly equal. So that means that both of these capacitors, they're both going to be able to store their full amount of charge. And so our capacitance, instead of being an inverse equation here, is just going to be a regular equation. Our total capacitance is going to equal our capacitance across element 1, our capacitor 1, plus our capacitance across capacitor 2. So we're just going to add up our total capacitance there. Now, just to make sure you understand this concept, it can be helpful to think of a metaphor for this difference between series and parallel circuit. Imagine you are going on a highway and you have to stop to pay a toll. Well, if there's like 10 toll booths, so there's all these different branches you can think of in the circuit, there's all these different paths the car can flow through, which would be like a parallel circuit, then a lot of cars are going to be able to go through at the same time. But if instead of having 10 toll booths, you only have one toll booth, like you'd have in a series circuit, each car, they have to line up, right? So one car goes through at a time, and then you can't get as many cars through at once. So you can just think of that metaphor to help you remember this difference between the series and the parallel circuits. So I hope this helps. Please drop a like if it did, and subscribe to my channel for more content like this.